Hey everyone. Today we are going to talk about mean absolute deviation. Mean absolute deviation, we shorten it and we call it the MAD. You will need a calculator for this lesson, and you can also follow along by printing out your notes that we linked in Google Classroom. Okay, let's get started. The MAD of a set of data is the average distance between each data value and the mean of that data. There's a couple steps that we're going to follow to find the mean absolute deviation. Step one, we're going to find the mean or the average of that data. You learned how to find the mean last week. It's the same steps. So find the mean first of all the data. Then step two, you are going to find the positive difference between each data value and the mean. Remember, difference in math means subtract. When we're finding the positive difference, that means we're using the absolute value of the difference. Step three, find the mean of all of those positive differences. That's where we get the mean absolute deviation from. It's the average distance each data point is away from the mean. And we're using the absolute value of those differences. So mean absolute deviation. If the MAD is low, what that is telling you is that all of the data points are very close to the mean and the data is not very spread out. If there's a high MAD, that means the data points are very spread out over a large range of values. So the mean absolute deviation is giving you a numerical value that represents a measure of variability, or we also call it the measure of spread. It's giving you a numerical value that describes how far apart the data is on average. If you have a low MAD, that means that there's less variation, the data is more closely clustered, and it's more consistent. If you have a high MAD, that means there's more variation in your data. The data is less clustered, meaning it's more spread out, it's less consistent. So if I just threw up these sets of numbers, if we looked at data set 1, it's a 7, a 13, a 9, a 5, a 18, and a 10. You can tell that those numbers are pretty close together. So we would expect that the first data set would have a low MAD. If I had a second data set, 58, 4, 203, 89, 11, and 139, wow, those numbers are very spread out. I would guess that that data set would have a high MAD when I calculated it. Okay, so we're going to try our first one together. Here are your numbers 3, 6, 6, 7, 8, 11, 15, and 16. So we're going to go through each step. The first step is finding the mean. You can work through this on your own and then push play and I'll reveal the answers, or you can just follow along with me on this one since it's your first time. Remember to always show your work. So to find the mean, we're going to need the sum of all the numbers divided by the number of data points. And this is where it's okay to use your calculator. Our data points are in order from least to greatest, but they don't have to be. Did you do it yourself? If so, awesome job. If not, let's move on and do it together. When I add all those numbers up, I get 72, and then there are 8 data points, so 72 divided by 8 is 9. If for any reason you do not get a whole number, you can round to the nearest tenths place. Okay, so now we are going to find the difference between each data point and the mean. The mean was 9. We're going to use the chart that is on the notes. If you don't have a chart, that's okay. You can make one. Sometimes you're not going to get a chart of your own. You would just have to do it yourself, okay? So I have the chart, and the middle column says mean. That is the easiest one to fill out. You just write the mean all the way down. In this case, it was 9. In the column all the way to the right, this is deviation from the mean. So you're going to write a subtraction statement that shows how far away each value is from the mean. I always start with the mean first. So the first one, I would write 9, take away 3, and find the answer to that is 6. The next one, 9 take away 6, that is 3. And the next data value is exactly the same. And we move on again. 9 take away 7 equals 2. 9 take away 8 equals 1. Again, sticking with that same pattern, I start with 9, take away 11. I actually get a negative number here. But remember, I'm taking the absolute value of that number, so I just get the number 2. We're just trying to see how far away is 11 from 9 or 9 from 11. So we're finding the distance, and the distance is not a negative number. So we take the absolute value in case our answer became negative, okay? You could have easily written 11 take away 9 and gotten 2. But I just wanted to show you where the word absolute comes from in the phrase mean absolute deviation. Same here. The distance between 15 and 9 is 6. And the distance between 9 and 16 is 7. So these are all of our values that we're going to use to do step number 3. Make sure you have all these written down either on your own sheet of paper or in your notes. Okay, so here's all of our data points on a number line and all of the distances shown to you. Remember, our data points were all spread out. I had a 3, a 6, a 6, a 7, a 8, 11, a 15, and 16. My mean was 9, which you see in the center of that picture. And then all of my data deviations are shown to you graphically here. For example, the number 16 is 7 units away from the mean. You can see it on the number line. You do not have to draw this number line each time. We just wanted to show you a visual representation of what we're really doing here. Okay, so we've got all of these numbers here, our deviations. Now the last step is to find the mean of those numbers. Again, your first step to finding the mean is to add all of those numbers up. So I'm going to add 6 plus 3 plus 3 plus 2 plus 1 plus 2 plus 6 plus 7. And I get 30 when I'm using my calculator. Now I just need to use that number to find the mean. I've got a total of 8 data points. So 30 divided by 8 is 3.75. Now I know I said before you can round to the nearest tenths, but that's in step 1. Since this is a terminating decimal, I can just use all of the data points here, or all of the place values here. So my mean I can use as 3.75. This is the mean absolute deviation. What is the mean absolute deviation tell us about our data? Well, it's telling us that the average distance between each data point and the mean is about 3.75 units. So the data is clustered closely together. It's pretty consistent. There's little variation in my data here. All right, why don't you pause the video here and you try the next one on your own. After you finish all the steps, you are going to press play, and then I'll be ready to reveal the answers. All right, so we're ready to move on. We had these numbers: 418, 400, 328, 325, 307, and 300. So we're going to find the mean. We had to add up all of the numbers and divide by how many there are. Did you do that? All right. So when you add up all the numbers, you get 2,078, and there are 6 numbers there. So we rounded to the nearest tenths, and got 346.3. Now you need to find the difference between each data point and the mean, which was 346.3. Write down all of the differences. You can use the chart. Did you do that? Here's what it should look like. Again, in the mean column, you just write all of the mean in every row, and then we're going to subtract. Remember, we're using the positive value of the deviation in case you get a negative. And it all depends on the order in which you write your subtraction problem. So the deviation from the mean in the first value is 71.7. In the second value, it is 53.7, 18.3, 21.3, 39.3, and 46.3. If you did not have these in your chart, pause the video and redo your subtraction. Here's just another view of the deviations written next to those numbers. The third step is to find the mean of those numbers. So first we find the sum of the differences, just 250.6, and then we divide that number by how many numbers there are, which there were 6. So the mean absolute deviation is 41.8. If you got that, awesome job. The last question here in this problem says, what does the MAD tell us about our data? Well, again, the average distance between each data point and the mean is 41.8 units. This means the data is not closely clustered, it's inconsistent. There's going to be a lot of variation in this data. So I would say that a range of the MAD that is a higher MAD would be anything greater than 15. Anything lower than that, I would say you've got a pretty low MAD. But if it's greater than 15, then you've got a lot of jumbled around numbers. That means there's just a lot of variation in your data. Okay, you've got example number 3. Try that one on your own. When you're ready, push play and we'll go through it together. All right, so I did not go through all the steps with you. I just highlighted the main points. We had 88, 65, 70, 72, 95, 80, and 106. I found the mean to be 82.3, and then I found the differences between the mean and each data point, and then I averaged those together to get a MAD of 12.04. If you wanted to round to the nearest tens place, then it would just be 12.0 or 12. All right, you try the last one on your own. When you're ready, push play and the answers will come on the screen. Okay, we have the numbers 7, 13, 9, 5, 18, and 10. The mean between those numbers is 10.3. The deviations are listed on the screen. When I found the average of those deviations, I got 3.43. If you wanted to round to the nearest tenth, it would be 3.4. I hope you guys did well. Have a good day.